Well, good evening. Welcome to another episode of Warbird Tube. Tonight, we're going to be talking with Neil Osborn and Randy Kraft from AirCorps. They're going to give us an update on P-38 Lightning restoration that they are working on. Gentlemen, thank you for joining us all the way from Bemidji, Minnesota, which I believe probably has warm weather this time of year, other than, like in December.
Yeah, it's a little chilly. Thanks for having us.
Yeah. Real quickly, Randy, what's your background and how long have you been with AirCorps?
Well, originally I was in construction. I was a carpenter for about 13 years prior to working here, but I really didn't have much aviation background before this. I just thought, hey, I'm going to give it a shot. So I applied and I've been here for 10 and a half years.
Wow.
So I've been here for, I think, 5 years now, going on 5 years. Before I was in civil construction, so dirt work is what we generalize it. Running heavy equipment, stuff like that. And saw this job and I like working with my hands, so here I am.
Well, there you go. Well, we're going to talk about an intricate piece of history that you gentlemen are working on, the P-38 Lightning. It's a favorite of many, many people, and we'll get into some of the details of what they're doing in the restoration and actually their process of how they restore not only this P-38, but all the other great restorations that have come out of AirCorps. But first of all, if you're joining us for the first time or you're a loyal Warbird Tube fan, we're thrilled to have you with us tonight. If you enjoy what you see tonight, don't forget to spread that word across your favorite social media platforms. We do appreciate it. Now, Warbird Tube is made possible by the Commemorative Air Force. To find out more about the CAF, our events, our aircraft, many of which are on tour this summer and fall, just visit our website, commemorativeairforce.org. Now, as you're watching tonight, Neil and Randy are going to talk about all sorts of things, some technical, some not so technical, but you will probably have some questions about this P-38 restoration. We'll just type those in the chat box, and we'll try to answer them either during the presentation or before we sign off. So with that, let's get our presentation underway. And gentlemen, tell us a little bit about this P-38 restoration. This is a late model P-38. It's an L model, to be exact. Is that correct?
Yep, that is correct. So here's some general facts about P-38s. Like Steve said, we're working on a L model. It is the most produced variant of the P-38. I think about 3,900, if I remember right, they produced. Some unique changes they made, and we'll talk about it as we go. Aileron boosters, it was like adding power steering. So most of the old Warbirds, all of the old Warbirds is mechanical. So you got cables running through the whole structure. With the aileron booster, they hooked up hydraulics to it. So as the cable would turn a pulley on the booster, it would add some hydraulic horsepower to it to help out in the controls. They added some rocket mounts. One of the big complaints especially in the European theater, all the pilots got super cold up there. Their hands, their feet, sometimes even coming back with frostbite. It was pretty bad. So they figured they had to add something to keep the pilots warm up there. So they added heated clothing and some plugins for that stuff. And then a big thing with the P-38s and a big design feat, they were exceeding the speeds of some of the other Warbirds, and they were having a physics problem. So the compressibility, they were going so fast that the air was compressing going around the wing. And they added these dive recovery flaps, and it wasn't to slow the airplane in any way, but it was to change the airflow going over the wing. And we can go into some more of those details as we talk about the assemblies, but yeah, that's P-38. So in our shop, the first phase is the customer comes to us and they have a rough ROM. And so once we get that rough order of magnitude, then if we see that this project is fitting for a complete design and on the computer, then our CAD team will go through and design each individual part based on the original drawing of the manufacturer. And as they complete each part, they'll build up the assemblies, and then eventually they'll have a full airplane modeled up in the CAD software. And we'll see how that helps us in the following slides. We'll see how that helps us with the rest of the project. So the next phase, what we see on the floor is you got inspection and disassembly. So this is where you'll start seeing components of the aircraft moving into the shop. We'll disassemble everything. Well, backing up, prior to that, we 3D scan them to help with the CAD modeling of it. And so that'll give them a sense of how it was originally designed, and that helps a lot with what they call the loft model. That's the outside contour of the aircraft. So once they get all those scans done, we will start drilling it apart, cleaning and inspecting, and see what we have to work with. And then next we order parts. And when we order parts, we don't just call up Aircraft Spruce and say we need some new parts. So that's where we turn to our in-house fabrication shop. And on the next slide, we can see some pictures of some parts being made. So with the 3D model, we will operate all of our CNC mills and routers, and every part of the airplane starts as a flat piece of metal, and somehow we need to build an airplane part out of that. So with the help of the CAD models and the CNC machines, we'll make tooling blocks, and then from the tooling blocks we'll also cut flat patterns. And after we do that, then we'll put it in on top of the tooling block. We'll either stretch form it, rubber press it, drop hammer, stuff like that. So that's kind of the other side where me and Randy are on the restoration side. So that's all behind the scenes to us a little bit. The next slide is where we step in, and fit up phase. So this is Randy's artwork here, so we'll let him talk a little bit about it.
Yep. So when we receive a new part from, the fab shop and whatever, we have to compare it to the original drawings, like in the bottom left there, or I guess probably your right, I don't know. But anyways, so basically what I do is I just lay out all the stuff based off the original drawings. And that kind of helps you to determine where all the stringers go and everything has placement. And then I'll use that 3D model to pull some measurements off of to see how that compares to the original. And that's just kind of that step, you just keep going on doing basically the same thing throughout the rest of the structure.
I think this is the longest process of the whole restoration process. This is definitely the longest. We have on a P-38, there's 40,000 parts, and that's just in the airframe. So when we're building these large components, this here is part of the forward boom. This is this is on the outside panel where the air scoop would be to suck it into the turbo, and that's why it's all beefed up behind there. But the forward booms probably have at least 2,000 parts, just guesstimating.
Yeah, probably.
So that's where we have to measure, cut, form every one of those pieces. And like you can see in that 3D model there, we got a rib behind there, and then we have a stringer, and then we have the doubler on top. Well, we have to make sure that when we drill that hole for that rivet, it's got enough edge distance on every piece of material, because your rib's going vertical and your stringer's going horizontal, and those two, that crosshair has to line up. So, and that's one intersection out of hundreds. So it's over and over again. We just got to make sure everything is meticulously lined up.
And that's why I like to draw everything out, like on the skins and the webs and stuff like that, because it just creates that visual in real time, you know, versus like the 3D model.
Helps you visualize. And if something's not right, you can scratch it out and move it over a little bit.
You know, you can mark joggles on the back of that doubler, and you know, then you can shift your rivets over if you have to, just to avoid landing in the joggles and stuff.
Yep. And everything we do, you got mainly 4 different sizes of rivets. You got a number 3, 4, 5, and 6, and that's ranging from 3/32 to 3/16 of an inch. And you can see here, there's a lot of silver clecos, and we call those pilots. And they're also the size of a number 3 rivet. And so everything we do for going on months, depending on the project, the entire thing will be held together by silver clecos.
Yep.
And then the last step we do before disassembling it and sending it to paint is we upsize all those rivets to what they're gonna be. And those pilots also help us if we do make a mistake on laying everything out and we don't drill it quite right. We can fudge those, because a number 6 rivet is twice the size of a number 3, so we can kind of move it over a little bit if we need to. So it's a very, very time-consuming process for sure. And nobody's ever done one. Well, a couple of people have rebuilt them, but since the 40s, nobody's really dug into these structures. So it's kind of, everyone is a one-off, so it takes a lot of time. So next up we have, what did I put next? Oh, we can get into some of the details of reading the drawings. Randy here has been doing the most work with these Lockheed drawings, so I'll let him describe this a little bit.
Yeah, I mean, there's definitely differences between Lockheed, North American, Republic. Specifically on Lockheed, you can see the little rivet code in the bottom there. And
all
the stuff in the green, where it's all circled with numbers in it that tells you the different spacings and sizes of the rivets. You know, some other manufacturers, they'll actually just write it right above it, you know, AN 426, you know, 83 or whatever, you know. So this was definitely kind of a different process than I was used to, jumping into the Lockheeds versus the North American. But you know, it's always a challenge to kind of decipher all these different drawings, you know, from the different manufacturers. Let's see.
So down in the bottom left, we have the full drawing. And that drawing, when printed in full scale, is, I don't know, I'd say that drawing is probably 6 to 8 feet long, full scale, somewhere around there. And it's huge. So we have to zoom in. Like, so if you got that red box, it's up in the upper right, zoomed in there. So that's where we zoom in, and we got to find what we're looking for. And that's another hard part about Lockheed, is with North American, they kind of led the way with how they designed the bill, or the drawings. They added the bill of materials, and that's standard in modern engineering, where you'll have a bill of materials. Every part that's on that drawing is listed on the side of the page. Lockheed didn't do that. And so you got to hunt and peck where each part is. And the bill of materials, it was very helpful, because you got the part number and it would tell you, like, kind of material spec for that part and the size of it. But then it would also tell you where it's at on this drawing, because this drawing is so big. So it would give you station lines on the drawing. And so it would tell you it's in section 13 or whatever. Here we got to hunt and peck for it. And then, like, if you see the yellow circle there, that's a cross section. So if we want to see something a little closer up, we see that cross section, but then we have to hunt and peck for that cross section, figure out, we got to zoom back out. And then we got to be like, okay, where is that cross section? And then we zoom into the cross section. And then, so it's we spend a lot of time on the drawings just trying to find what we're looking for. And then there's notes. There, like Randy said, there's the rivet code. So you'll see little triangles and numbers just all over the drawing. And then you have to jump here, and you have to jump here, and then you have to go there. So it's going, navigating drawings is crazy. But then that's just one drawing.
Yeah.
Then it'll tell you that you have whatever part number on there. Well, then you go to that drawing for that part number, and then you do the same thing there. And then you find another part number on that drawing, and then you go here and you go look at that drawing. So it's that in and of itself is super time consuming.
So all of these drawings that you have, they're all on computer, or are you actually going to physical paper to look at them?
This is all microfilm. So okay. This is all digitally uploaded to our servers and to AirCorps library online. And so it's nice there because we can work on the computer, type in the number, quick search, there it is, and pull it up, zoom in, print it off. We print off a lot. We do some highlighting, kind of make it a little easier once we find the information we need.
Yeah, it's nice to have paper so you can bring it to the fixtures and stuff like that, right, to actually work on what you're doing. Besides running back and forth between your computer.
Most of our big projects, we have very large binders, and it's full of printouts. So you'll have like the spar assembly. You'll have all 10 of those drawings stacked up and highlighted. And then you'll have a skin assembly in another section of the binder. And it makes it easier to jump back to the information we need.
Sure. Eric posted a question for us. How accurate are the original drawings? I mean, have you, when you're looking at the actual assembly versus the original assembly versus what's on the drawings, do they match?
I would say 95% of the time.
Yeah, it'll tell you if there's a different scale on the drawing, but for the most part, they're all drawn to scale. That's why these drawings are so big.
Yeah,
you know, because you could actually measure off of those. Actually, some drawings will even have like a measuring bar on the bottom, so you can compare it regardless of what size printout you make, you know.
Okay.
Yeah, and as for the information on there, like I'd say 95% of the time they're super accurate. Like if it's on the drawing, you should be able to walk to that original assembly and it's there. And if you can't quite figure out what that 2D drawing is showing, then you go to that original. And that's where having the original does speed us up, because like 2D, you're going to have like 3 or 4 different layers stacked up shown by dotted lines, and you're trying to decipher that. Whereas you walk to the original and it's like, oh, hey, it's like that. And that's what's really cool is our engineers over in the CAD office, they put a lot of time into it, drawing these and looking at the originals. So we can go into the CAD model and highlight parts, delete them, kind of spin it around. It gives you a 3D view of it, and that speeds us up also.
Good.
It's nice to take snapshots of the screen of the 3D model oriented to where like you want to see. You know, you can zoom in, you can print it out, you can highlight it, you can write the part number on it, and all that is super, super handy.
Mm-hmm.
Very good. Eric has a couple of other questions. What scanner technology are you using? He's wondering if it's laser.
Yes, it's the 3D scanner. It has two cameras on it.
Okay.
And they put these little reflective dots on there, and that kind of like sets the basis. I don't know, kind of.
Yeah, you even have a spray that like reflects the laser back, so that it determines the depths and the shapes.
Yeah. So it's a laser scanner.
Okay. And if you can, what CAD software do you use?
What do we use?
There's Bobcat.
No, that's old school.
That's an old one. Well, I'm not quite sure.
We use SolidWorks.
Well, that's what.
SolidWorks is what they use.
All right.
Yep. Yeah.
We have an inquisitive audience. I'll tell you that much.
That's good. Those questions are fine. So next phase, we have, once we get all the fit up done, we drill all the holes we need, we take it apart, we deburr everything and send it out to paint. Then we get it back and you see a bunch of yellow parts, yellow and green most of the time. So then we start putting rivets in and putting the skins on, and then it starts looking like a actual aircraft structure. So that's a fun phase, I would say.
Yeah.
It's all fun, but
it's a lot of work, going through that process of disassemble and stripping parts and inspecting them to determine whether what's usable or not.
Mm-hmm.
So that's an exciting moment when you start hearing riveting going on.
Yep, and that's what we've been hearing for the last 2 or 3 days.
Good.
Nothing but riveting. It gets very noisy here in the structure shop. Everyone has headphones on.
Yeah, the picture we're looking at. So earlier on, we saw this. That's on the left side of the screen. The aileron from the original with the dent that's circled. So the picture that's on the right, is that the same? Is that the same assembly repaired, or is it a brand new assembly?
So that's the original assembly. So you see that red circle up there on that spar.
Yeah, where the dent is.
Yep. So if it came in the door and it looked like what's in the bottom right, we wouldn't have taken it apart. It's airworthy. So in the red circle there's where the aileron was crushed. And so that's where we took it apart. With the 3D scanning and the modeling, we recreated that spar. And so in the upper right-hand corner, everything after the spar or above the spar is all original, and the only thing new is that spar.
Wow.
So we try to reuse as much as possible. It's always a balance, because sometimes if it's an original structure that hasn't been played with before, in terms of like taking it apart, drilling, every time you shoot a rivet, it swells that material. And every time you swell that material, it gets harder and harder to fill it again. So if it's an assembly that's been rebuilt once or twice before, that's where we kind of scrap it, because those holes are so big. It's going to take a lot of patching to back up all those rivets.
Yeah, it ends up being a lot of cracking in the holes too.
Correct. So, yeah.
Hal, one of our viewers, Hal, was asking along the same lines, how much of this project is original that's been repaired, and how much of it is new? Might be hard to estimate.
Well, the Aft Booms, I'm sure those are pretty much new, but we didn't actually build those.
Those newer. So the scope of this project is we're just assisting a shop down in Texas. So our scope on this project is we are building up the forward booms, the gondola, a bunch of miscellaneous structures. The customer had received the aft booms, the horizontal, and the elevator. So we don't know the full picture of those parts. So then we're building the structures up here, rebuilding some components, and then we're shipping it to CAF Aviation. and this is their project, and they're going to assemble it all, run all the lines, hook everything up, and they're going to fly the aircraft. So
Okay.
where some of the parts came from, we're not 100% sure.
Well, when we receive original, structures, like we had a gondola here,
Mhm.
and I had to really kind of fine tooth go through it and mark things that looked like they could be reusable or not. And then kind of go through the process where you decide to drill those parts off, and then you go through the stripping or blasting or whatever, and then once again determine whether it's good or not, and then we try to incorporate that as much as we can into the new builds.
And that gondola was a different model, correct?
That one was, yep. It was a J model.
So that's also a big thing. Like customers will send us all their P-38 parts, and they're like, "Hey, I want an L model." Well, when you look at all the different models, I mean, how many models of the P-38 are there? It's how high did they go? Anyways, so they had a lot of different variants. So
Sure.
we received H model parts and J model parts, and I can talk a little bit more about that when we get to the leading edges. But I took, I think, 3 different airplanes worth of
Leading edge
parts,
yeah.
and because they changed, leading edges changed quite a bit throughout the whole process. But I would take one chunk out of the J model that was good, and then the L model part that was bad, which is what we're trying to build, I would piece it together, scab it together with that. And so we try to do as much as possible, but when the model changes and it changes all the parts, then we gotta, if we don't have the parts, then we gotta make them. So to answer that question, I'm not quite sure how much is original.
As much as possible.
As much as possible, 100%. So with assembly phase riveting, we were talking about how noisy it gets, and so installing rivets. Everything on an aircraft is usually held together with the main fastener is rivets. Then you got bolts, screws, hard fasteners, and then spot welds for structural. So I'd say rivets are 95% of what holds an aircraft together, and they're solid rivets. They're not your little pop rivets that you get at the hardware store. So you see up there in the white photo towards the top left. So the center two, one is a brazier head or button head rivet, and then the other one is countersunk, a flush rivet. So that's how it starts out before we drive the rivet. So we drill the hole, we put the rivet in, and then to the left of that, you see 2 things above and below the rivet. One side is a rivet gun, the other side is a bucking bar. And so it's like an air hammer. We have different sizes for different size rivets. But you'll put the rivet gun on top, and it's a hammer, pneumatic hammer, and it'll sit there and beat the rivet. And what that does is the rivet gun doesn't bounce up and down, but in turn, the bucking bar on the back side bounces up and down super slow or super fast, like you don't see it moving, but that creates what is called the shop head. And that is how rivets are upset, is the technical term, upsetting rivets. Multiple ways to do that. Most of the skins and a lot of the structure is put together with what I just described with a rivet gun and a bucking bar. But some of it, if we can get it, get a squeezer, what you see down in the bottom left-hand corner or left-hand side. So the bottom corner, those are handheld units. So if we can get those in and around the material we're working with, it gets to both sides. So it'll hold that factory head and squeeze and make that shop head. No different than that big one, that floor mounted one. Same thing, just a lot bigger capacity, get bigger things in there. And then over on the right-hand side is Randy's domain. So Randy's been here over 10 years now. And out of everyone in the shop, he is the most creative. And like, I can't even see rivets sometimes. And he'll be like, oh yeah, I got this perfect bar. He'll reach up in there around that corner and just tap that rivet. And it'll be the perfect rivet you've ever seen. I don't even know how he does it, but he is probably one of the best in the world at bucking rivets. And those bars on the right-hand side are all custom for getting in. It's mainly for closing out skins. So explain to us, how do you buck rivets as well as you do?
It's practice.
Lots and lots.
When you shoot a million rivets, you know, you're going to get used to it.
Yeah, it's funny when you talk quantities. My first assembly here was a P-51 horizontal. And without the structure, the rivets in the structure, just the rivets in the skin, it's over 2,000. I think it's around 2,200 rivets holding the skins on just that little horizontal. And like he said, tons and tons, millions of rivets. Yeah. It goes in a hurry. Like you wouldn't think, oh, I just shot 500 rivets. Well, you did that in half a day. Like it's pretty crazy.
Then one rivet could take you 5-10 minutes, you know, it just depends on how difficult it is.
Correct.
To get to. You have to try again or whatever.
Yep. Mm-hmm. That is a skill I haven't mastered. I'm getting decent at it, but definitely not Randy's level.
Randy's an artwork level, right?
Oh, yeah.
Yeah, he is an artist too. You should see his drawings. Oh, what do we got next? Oh, leading edges. There we go. So this was a fun project. So I talked a little bit about it. So if you see on the right-hand side, well, let's back up a little bit. Big picture of the P-38. They had many different variants. So the first one was designed like any other structure that you would see in an aircraft, with ribs every 10, 12 inches, and just a skin riveted on there. Then they went to an intercooler. So, and to put this in perspective, this is about 16 feet long. So the second variant, they had the intercooler ducts running up through the leading edge. And that was on the around the H model, if I remember right. And then in the J and L models, they went with this corrugated wing panel. And then, so there's each top and bottom section is made up of 4 corrugation panels. So these ones would have been super difficult. And you can see in the very center on the bottom, that's one of the original corrugation pieces that we received. That guy, if I remember right, I feel like we used that one. That one looks pretty good. So I forgot to put some other pictures in. But so yeah, there's 4 corrugation assemblies and per upper and lower. And then what that allowed is for them to put fuel tanks in the wings. So they added 55 gallons to each wing out on the outer wing. And what else can we say? They're all spot welded. So we talked about rivets make up most of the structure. Spot welds, this entire assembly here, other than the
rivets.
Yep, tack rivets and the hinge being riveted on, and then the ribs were riveted in. But you can see it's kind of tiger striped, and that there's a close-up picture there. And so every white stripe is where there's a line of spot welds. And that white stripe is actually acid etching. They used it back in the day. We do the same thing, same process. We apply the acid. It removes all the contaminants from the surface, and then we spot weld away. The fun part about working with all these original pieces was they were spot welded on originally. We had to remove a spot weld from an assembly. You can only keep one piece. So there's two pieces that make up this assembly. You got the outer skin, and then you have the corrugation on the inside. So we had to sacrifice the skin, which was all corroded and not very good. So we grind out every one of those spot welds, very time consuming. And then we peel the skin off. Then we sand it, make it smooth. Then we put the new skin on top of it. And then we have to spot weld that new skin on. And spot welding aluminum, any spot welding, it's called resistance welding. And that's the biggest thing to remember when spot welding is resistance. Everything is based off resistance. And so if you change that resistance, it's going to change how that spot weld performs. And so if you weld over one of those original spot welds, it changes your resistance. So it's harder to get through that original spot weld than it is that fresh material. So that was the fun part, is that spacing for every one of those panels is based off the original spacing, but going in between every one of them. So yeah, that was
they
fun
were
part.
close together.
They were very close together. It sat there with a pencil and marked half of them, the ones you couldn't really see to the naked eye, just so you could see it, so you could put a new one on. So the wing spar there, you can see is in the center of those two corrugation panels. That guy was all new. New skin on each one of the leading edge panels. But the corrugations were all original. Those would be very tricky parts to make because they were just about 4 feet a piece. Like that whole assembly is 14 feet, 16 feet. And so a little under 4 feet was each one of those corrugation panels. And to do that, to move that much material, each one of those corrugations was probably an inch, over an inch, each one of those beads. And back in the day, that would have been done with match tooling on a drop hammer. And that's very expensive tooling and very tough to move that much material.
Well, those are massive drop hammers too.
Yeah.
Sizable building.
Yeah, we have a drop hammer, but I'd say it's probably a baby drop hammer in the drop hammer world.
But there's a lot of other original parts we used on those too, like majority of the finger plates on the bottom. I think that some of those doublers were original, like one of those. I think the other one was probably.
Oh yeah, and in the center of the spar, there's a bunch of brackets there. I should have had a close up of that. But on the back side of that would have been where they bolted on the aileron booster. So there's big castings. There's 3 of them in there. And in each one of them is where they send bolts through from the aileron booster and stiffen that area up. So those are all original. Most of the attached fittings that we'll see a little later are all original. Those are an interesting Lockheed design. But yeah, that's the leading edges. Oh, here we go. Fun stuff here. It's kind of artsy there. So critical dimensions, when we're building aircraft, there's some things like if a loft isn't quite right, center of the wing isn't quite perfect, it'll still fly. But if your wing doesn't bolt up to your center section, I don't think it's going to fly. So circled it, I got a bunch of circles there. So everything in red, those guys go together. So you got the center section spar and the wing spar. And those fittings have like a bunch of fingers and they interlock, and then a bolt goes through them. Like I was saying, most of those, all but one of those wing fittings are original. We did make one of those. That was also fun because you got the spar, and the spar cap is, it kind of like forks, and then that fitting slides in the center of it. And like I was saying, they're all original fittings. So originally what they would have done back in the factories, they would have slid that in, and they had a jig that sat on top of the spar, and then they drilled all their holes. So they didn't have to line anything up. They slid the spar into the fixture, they slid the fitting in, and it was locked in the fixture, drilled their holes. So on these guys, since they're original, they were new spar caps, so no holes, and then all the holes were already in the fitting. So then we had to figure out where that hole was through all that material and do a perfect line drill and keep the tolerance tight, because those bolts have to be tight, because if that allows it to slip any, you give it an inch, when that wing is flexing up and down, it's going to take a mile, and it's going to wear and tear. So you can see how those two go together. And then down in the bottom right, you have the red circles again. Those are those same wing fittings. Then that wing fitting ties into a casting that's on that rib. And then that it transfers up to, or if you would tilt the rib for the leading edge, on the bottom of it, you would have the fitting to hook up the engine mount. And then down in the bottom left-hand corner, that's part of the forward boom. And in the green, in the bottom left, that is also where the engine mount hooks up. And then if you go to the center, the CAD model down there, you can see how those 4 assemblies coming together has to line up with one engine mount that bolts up to it. So our fixtures have to lock all this in. You know, everything's got to be dialed in, because we'll work on one assembly at a time, and then once we pull all the assemblies together, they all have to bolt together with a very tight tolerance. And how we keep all those dimensions, if we see on the next page there, we get to see how we do that. And you want to talk about fixtures a little bit?
Yeah, so we've kind of started designing the fixtures. We'll utilize the model, and we'll determine which is like the fittings and castings and gear attach points and all those different things that are really important. And we'll try to create a fixture that will pick up all sorts of different spots that make the most sense for the build. To have like the CAD team rely on that don't really build the airplanes, they don't see those kind of things. So that's kind of became a part of our what we do here. So we do a preliminary designs, and then we send it off and we communicate with the CAD team, and we create these, which they look very complicated.
They do, and you can see some of it behind us. So that's a gondola fixture, and up in the center you can see the complete gondola in one big frame. And then around that you see 3 smaller fixtures, and those are the 3 that are stacked up. Right closest to us is the nose assembly, which is in the upper left hand corner. And why we split it up is that allows, instead of 2 guys or 3 guys working on the whole gondola, tripping over each other, like, get out of my space, we can split the fixture up, and we can have a working room around it. So you have 3 people doing their own thing around each fixture. And then it's also designed into it that once those side panels are done, they will slide together, and we'll change some brackets around. but we'll slide those two fixtures together and start attaching all the floorboards and everything in between the two side panels. Then we'll slide the nose panel up to it and bolt that on. So we kind of took a play out of the North American playbook. North American, they designed everything in the manufacturing world. And so a P-51 fuselage was built in two halves. And then it would slowly come down the assembly line, come together, and that's how they kicked it out the door so fast. So we kind of took their play and used it on the Lockheed.
Well, Lockheed, we have pictures of the, the shops or manufacturers of these where they do have them all in separate stages, kind of like that. That's kind of where I got the idea for the gondola nose fixture.
I feel like the whole gondola though I saw one big fixture.
Oh, a lot of them, they built them upside down.
Yeah, that was interesting.
It was weird.
Yep.
So we didn't do that. We could.
Yeah. No, it helps us because we can look at the drawing and we can walk over and we don't have to flip it over in our mind. Yeah. I'm sure in the factory they were putting one part on every assembly and they could do that over and over again. Ford booms. This was a fun one. Mm-hmm. This was Randy's project.
Yep. Yeah, so as you can see, like in the top right there, that's the turbo shelf. That was pretty much all stainless steel. We actually made a fixture for that too, to build that separately.
Because we built this in 3 different fixtures also.
Yep. So we built this just kind of like the gondola. So we built it in 2 halves. And then we built the top, and then we mated them together.
The turbo shelf was all stainless. And that assembly there is, how long is that? 5 feet long? No, it's 4.5 feet long. So to put it in perspective, CAD models are always difficult because you can see this model on the computer screen, but you can't, there's no scale. You can zoom in and out. So like a drawing, if you see the complete assembly, that's about that big. And then you see the little parts on it. With the CAD model, you can zoom in and out and you can't really put it into perspective how big it is. So the CAD model, that turbo shelf is probably 4.5 feet long. And every part on there is spot welded. And that's how Lockheed did it back in the day. Everything was spot welded. And I put what I named the Bermuda Triangle on there. So you would get lost in there. So the fun part about spot welding is you kind of go through the process of welding it in your mind. Because you put a part on, you spot weld it. Then you put another piece on, you spot weld it. Well, if you mess up that sequence when spot welding, like I said, to remove spot welds, you have to destroy. You can only save one of those parts. So if you mess up and, in stainless is even harder to remove spot welds. So if you mess up the assembly, it's kind of catastrophic. So you go through the process in your mind and you're like, okay, if I do this, 1, 2, 3, 4, oh no, 3 and 4 need to be reversed. And then you run through the sequence again and you kind of cleco it together, clamp it together. Can you move this if you clamp that? So you're kind of mocking it up and running through it in your mind over and over again. It's kind of paralyzing at times, but that little triangle on the very right-hand side, I nicknamed it the Bermuda Triangle because it'll be a little difficult to explain, but it's a triangle up there on the slant web, and it's got spot welds on 4 different lines of it. And that whole space in there is closed and you can't see in there. So you have to figure out how to work your way out of it. And that was probably one of the more difficult parts of that assembly. And of that assembly, there's like 5 large components. You got the floor, and why we call it the turbo shelf, actually, to back up a little bit, the turbo actually sat right there in that, on that floor that you see with a hole through it. So the turbo would sit right there, the exhaust would come out the back, and air would come in the bottom through the side of the forward boom up to the bottom.
This is a little football thing.
Yeah, they nicknamed it the football. So air would come in, go through a couple ducts up to the turbo, and yeah, and that's why it's all stainless, because there's a lot of exhaust gases going through a turbo, and it gets pretty toasty. So yeah, okay, back to you. I hijacked it.
Well, you know, it's one of the interesting parts about building these things is actually trying to figure out how to build yourself out of it.
Yeah, and if we go back,
well, we can move on forward, but
no, way. I added this picture because you can
peel the skin back.
Yeah, because riveting again, you have to be able to get inside. So you got the outer skin of the forward boom, you have all that stuff in the wall, and then you have a skin on the inside. So you have to figure out how to, and if you look in, there's that inside view where you see the turtle deck overhead, that yellow back panel, that's the aft bulkhead. And then on the side panels, you see just these little access holes. And that's how you have to close everything out. So you have to reach up there, I don't know, 12 inches in this space. That's probably like, it comes down to nothing. So it's from nothing to maybe 2.5 inches wide.
So that's where the custom bars come into play. And
then you have stringers sticking out. So that closes your space.
Find a person with the right length forearm and whatever you can get into the hole.
Correct. How flexible are you?
Yep.
that comes into play a lot. My hands are pretty big, so I don't think I'll ever get good at riveting. Yeah. Next page, what do we got? Ooh, empennage.
Aft boom.
Aft boom. So you got on a P-38, you got the forward boom, which is right behind the engine. That's where the landing gear are. And then you have the aft boom behind that, bolts to it. And then in the upper left-hand corner, get my directions straight. Upper left-hand corner, you got the aft boom. And that's its technical term, aft boom. And so that is the crossroads of what holds this whole empennage together. I think I counted 15 assemblies on this whole empennage. When you count verticals, you got 4 verticals, you got upper lower verticals, upper lower rudders. There's about 15 assemblies that come together right here. And the aft boom is the crossroads of all of that. So it ties everything together and up to the aft boom. And you can't just have a solid block of aluminum there holding it all together for strength, because like I said, everything is mechanical, all these control surfaces. So you have to have room for all these cables and pulleys to come in and turn corners and counterweights to move up and down. So you got aft boom. You can see that one panel is removable. That's the bottom outboard of each side comes off, so you can access all the pulleys and cables in there. Beside that, you got that is the rudder trim tab. So cables would come in, spin that drum, and then that transfers it to a thread, and that threads a push rod in and out of the rudder, and that's what's running your trim tab. And then you can see all those cables and how they have to go in, turn corners and stuff on the right-hand side there. And then you can see bottom left-hand corner, that's everything except for the lower verticals and lower rudders on there. And then interesting notes on counterweights. So the upper one in the yellow box, that is the external counterweight, and that's bolted on top and bottom, protruding forward from the elevator. And then the red box is what's internal. So that's inside of those aft booms. And that is also projecting forward from the elevator, and that's counterbalancing. So that elevator is a 20-pound assembly, maybe, probably around there. So that's a lot of control pressure to run that manually. So the counterbalance is kind of balance that playing field and make a balanced control surface. Interesting note that the yellow ones were not part of the original P-38 design. On the early models, when they were having issues with the, no, I can't think of the term. Anyways, compressibility, there we go.
Yep.
They were having compressibility issues, and it's a physics issue. It's not a design. Everyone wanted to blame this funky looking aircraft. And Kelly Johnson was constantly arguing the point that it's not a aircraft problem. They were blaming it. So when they went up and they were exceeding, I think they exceeded 0.68 Mach in some of their dives, and 600 mile an hour, roughly, I think, somewhere around there. And so they were reaching that compressibility speed. And what the pilots would come back and describe was a tail shake. And when nothing was happening on the tail, it was actually all happening up on the wings. And so they thought it was flutter in the control surfaces on the tail. So the Army Air Force demanded that they put those external counterweights on. And they went up. It still didn't fix the issue. It did stick to the rest of the designs of the P-38. They finally got the P-38 in their wind tunnel, and they figured out that it wasn't a flutter issue. It was a compressibility, a physics issue. And that's where they added those dive brakes. And it wasn't to slow the aircraft, but it was to change the airflow going around the wings and help them with the controls there.
Yeah.
So yeah, interesting design series of the P-38.
There's the aft booms.
Oh yeah, you got aft booms down in the bottom left-hand corner. Radiators were mounted on each side of the aft boom. Coolant tubing then in turn has to run all the way through the forward booms. So that's more stuff going through the walls. Spinners above that. So you had 2 spinners for the P-38. What else we got here?
Gear doors. Horizontal tips.
Yeah, so that's
wing tips.
Yeah, wingtips, those are all spot welded. Gear doors, those are main gear doors. So there would have been 2 on each forward boom. They were clamshell doors for the main gear. So those are about 6 feet long, 8 feet. No, those things are taller than me. So they're like 8, 9 feet long. They're pretty big. And if you can see in the fixture there with the yellow structure, the amount of twists.
Mm-hmm.
It's pretty crazy. It's easy to work with a square box, but when you have to work with the crazy bubbles, that's a fun thing about aircraft is it's all about airflow, and everything's curved, everything's smooth. And the P-38, I believe, was one of the first aircraft that used a lot of butt joints and countersunk flush rivets, trying to speed things up. P-38 really did change a lot of things in warbirds. I think it was the first warbird that commuted from the U.S. to overseas under their own power. They added drop tanks. They had the wing fuel tanks. So they went up and around over to Europe. Yeah, they set a lot of records with that aircraft. Components. So if we get components other than sheet metal into the structure shop here, and components could be anything: hydraulic fuel, oxygen, pedostatic system. That's all a component. Landing gear, that's a component. And if we have any airframe components, they'll go over to the components department, and they'll do all of our NDT inspections. So Magnaflux, Zyglow, Dye-Pen, eddy current, ultrasonic, like all those different, all the non-destructive testing is what NDT stands for. So anything other than a visual inspection. Electronics, you can see that's the coolant door operating mechanism. So a lot of, in the Mustang, it had a little electronics in it, but then it was hydraulic. Anyways, so that's the thing, that the oil temperature will say it's at this temperature, and then that converts it into hydraulics and how far the door opens to cool the aircraft off. Landing gear up in the corner. It's a tall tricycle gear aircraft, so those things are, I think they're big. Yeah, the aircraft stands 12 feet 10 inches tall total, so it's pretty far up there. And I think those, I could probably walk under a forward boom, and I'm pretty tall. So those landing gear legs are pretty tall. Then in the bottom center there, that's the aileron booster. So we've heard that a couple times. So that's, you can see your cable going up to that pulley, and then that would apply the hydraulic pressure to the ailerons. So, and then flap track linkages, you can see how it comes in kind of rusty in a pile of metal. And then we go through it, inspect it, and paint it.
Make it pretty.
Go. Yeah, make it pretty.
Yeah.
That's what we did.
Well, Randy and Neil, thank you for this look at the P-38 restoration. And we have a ton of questions, so you're not done yet. All right. Your shop is in Bemidji, Minnesota. Are all of the components that you talked about, the 3D, the components, the actual shop, everything is all located in one spot, right?
We have multiple locations in Bemidji.
Okay.
Actually, we have some locations in the cities too, depending on what we're doing.
But we're spread out. We have four different facilities.
Okay.
So we have the restoration shop, and the restoration in the organization stands for, it's the structures team, myself first, components, completion, maintenance, and then we have library, artwork. That all falls under the AirCorps restoration.
Right.
And then AirCorps Fabrication is a couple blocks away at their own facility, and they have a full facility full of all their machines and everything. And then maintenance hangars actually at the airport. We're not at the airport.
Yeah.
So that's a different facility. And then
Depot.
Oh yeah, Depot.
Depot.
Depot is right next to us here on the same land. They sell all the Warbird parts, Mustang, Stearman, everything you can think of.
Okay.
But yeah, the majority of AirCorps is here in Bemidji.
Okay. Were the microfilms provided directly from Lockheed Martin, or did you have a different source to find those?
Were what?
The microfilms? Did they come from Lockheed, or?
I thought you said microphones.
Oh,
Microfilm. Was it from Lockheed? We'd have to ask Esther.
Okay.
I know some of it did come from the team down at Disassembly Aviation in Texas. This is, like I said, their project.
Right.
So when they asked for our assistance, they sent us some of their microfilm. But Esther, who heads up our library, you know her very well, Steve.
Yep.
She found the rest of what we were looking for. So
Okay.
we'd have to ask her.
All right. Has AI made its way into this restoration process yet, or is that still to come?
Not the hands-on,
Right.
but part of what we do as continuous improvement is scheduling. It's a big thing on some of our plates. And how long is this assembly going to take? Well, what we do with our vast years of experience here, we look at previous assemblies and we look at similar. So if we're going to build, I don't know, Corsair, we're going to look at something, well, the P-47 wing was kind of like it, maybe, but this spot welding is going to add some. So we'll take the data from building a P-47 wing and we'll say, well, how long did it take to do that? And we do use computer software of various forms to organize it and guesstimate on how long it's going to take. That way we can have an accurate schedule for the customers and real timelines.
Good. Are you using 3D printing at all for either make parts or to use the 3D part to kind of see what it would look like?
Not too much. We have 3D printing.
We've done outside 3D printing for like rubber products.
Okay.
You know, like plugs for like the camera and the leading edge of the P-47. We had this, you know, it was very complicated to make that part because it was curved and oval shape. So we actually had one of those 3D printed.
And it's interesting because the CNC routers, I would say, are the opposite thing of 3D printing.
Yep.
So 3D printing is taking a flat bed and building something on top of it, right? Out of nothing. And whereas with the CNC router is taking this giant chunk of material and cutting it away until you have something. So we're doing the opposite of 3D printing. Like if we need, with our projects, we've replicated parts of aircraft so we can fit up to it. And the CNC router will shape it, put all the holes in it, and then when the mating assembly that we're building, we'll base it off that contour, all those holes. So we're doing the opposite of 3D printing.
Sure.
Pretty much.
All right. Sean has a comment, and this is a pretty good one. It sounds like neither of you did any kind of mechanical aircraft fabrication before. He says, you guys are quite bold and brave to take this on.
Well, we do cross train here, so we all get to kind of work a little bit in the fab shop and stuff like that to learn a lot of the processes. We don't use CNC machines, and we don't, lathes and stuff like that. We don't really dabble in too much, we can, but we don't usually. But we do, hand form parts, roll parts, planishing hammer, English wheel, all those different versions of processes for shaping metal. So
I will say when I was originally nosing around looking for an aviation job, so I started flying and I was like, oh, it'd be cool to be in aviation. And COVID kind of sped that process up for me. But I Googled aviation jobs and I saw this one and I'm like, that would be amazing. Like rebuilding warbirds, rebuilding history. Like how cool would that be? And I was like, nah, I can't do that. But it's actually Randy's video that I saw. I pulled up the website and I saw Randy and he was like, I was a carpenter, here I am 5 years later. And I'm like, if he can do it, I can do it.
There you go.
So, I mean, really like aviation it's AirCorps Aviation, and the aviation, you know, it's only scary because we don't know it, right? So unless you're in the aviation field, if you're not in the aviation field, it's kind of scary. But we're not looking for people to fly aircraft or wrench on them. We're looking for craftsmen.
Yeah.
is really what we're looking for. And that's where Randy and I excel. Like, we love working with our hands. We love building something, stepping back at the end of the day, seeing something that we've built. And that's honestly what it is here.
Yeah.
We're craftsmen. What?
There you go.
Yeah. We have a broad range of people here. We have the history buffs that know everything about every aircraft. They'll tell you where those aircraft flew, the different paint schemes on all of them. And then on the opposite side of the spectrum, we have just our people that like to work on something, build something. And whether you're anywhere in there, you'll fit in.
There you go.
It's more of a culture fit than anything else.
Okay. Theo's asking, and it may not be applicable to the P-38, but maybe with Mustang. But when your fixture shops build components for an aircraft, I mean, do you sell those to other Mustang restorations, for instance?
We do help other restoration shops out. Like this one, we're helping Disassembly Aviation. So,
right.
So they're working on some parts of the aircraft. So we will make parts for them and send to those restoration shops. Depot works a lot with a lot of the owners out there. And if they order, most of the time it's not a structural part. Most of the time it's a component. But yes, in the engineering team, we have multiple people that are focused on PMAing parts. So Lord mounts for the engine, those are PMA'd. So that team is working with FAA and getting the correct paperwork to bolt all these components onto the aircraft. So yes, we do work with other shops and owners.
Okay. Randy, being Mr. Rivet, after a long day of riveting, how do you find yourself relaxing and prepping for another day of another 2,000 rivets to shoot?
For a few hours, but
I like all the beard questions. Like, we're lumberjacks up here.
if you grow one, you got one. That's just
yeah. Salt and pepper. I'm working there, unfortunately.
So you don't have the original factory jigs to work with when you're putting all these components together. How do you did you create all the jigs that go together, or how do you make everything fit?
We sometimes receive fixtures and different things that come with the projects, but we still need to 3D scan them to make sure that all the attached points are proper. And then we alter them if we have to, or we do like you saw in that earlier picture where we design all brand new fixtures, and that way we know that all the modeling fits together. And that definitely makes a huge difference.
Yeah, it really depends on, going back to the very beginning, the rough order of magnitude or scope of work for the project. If we're building the entire aircraft, then we know all of our fixtures we make or we have in-house are going to work together. The Mustangs are tried and true. Well, we've done it over and over again. So we know all those work together. And it's based on our CAD 3D scanning. If it's something like we're going to replace one component of an aircraft, we would go out to the field, scan it, and then make a fixture just for that. To change where the attach points are, because sometimes they aren't perfect. Like he was saying, sometimes we get in older fixtures, and we can see behind us, this is kind of our new school fixture design. Old school fixture design was a giant steel fixture with steel points, attach points, and after they weld it, because when you weld, you can never hold it in its correct position. So then you have to go in there and you have to mill it and make sure it's perfect. With this new school, everything is cut on a CNC machine. So every point of every plate we know is precise, right on. And it's modular because, like I was saying, we have those gondola fixtures in the Ford Boom fixtures. We built them separate, and then we just swap some plates out and we slide it together. And it's almost like a third fixture in a way. So they're kind of a modular design. So that helps out a lot too. Yeah. And they break down, they're easier to store. I mean, they have a lot of advantages to them.
Good. How long will it take you to finish the work that you have been contracted to do for CAF Aviation before you turn all the parts over to them and let them put the airplane back together?
Another year or two.
Okay.
If I had to guess.
All right. Well, we talked to the gentleman, one of the gentlemen who's doing the Desert Rat B-17 restoration last week, and the question always comes up, when's that going to be done? He said Thursday.
Thursday.
Tell us what year.
I like that answer. Which month?
There you go. I think Judy is going to start a fan club for you. She says you guys are fantastic, so that's good. So you got your first fan for your fan club.
Thank you, Judy.
Lots of questions about beards, and the big one is, who has the best beard in the shop? Okay.
This guy.
There you go. Neil, Randy, thank you so much for joining us tonight and really bringing us some great information, not only about the P-38, but also about AirCorps and how you go about these fantastic restorations that you continue to turn out year after year. And we so look forward to everything that comes rolling out of your shop.
Thank you very much, Steve.
Thanks.
Yeah. And thank you, our audience, for sticking with us tonight. I know we've gone a little longer, but it was fun. Lots of questions. Still some questions that are out there. Maybe we'll see if we can get Neil and Randy to answer those when we post up on YouTube. So thanks again for being a part of this. If you have any comments about tonight's show or anything you'd like us to cover in the future, drop us a line at media@cafhq.org. Until next time, I'm Steve Buss for the Commemorative Air Force. Have a great night.